Good morning, students. Today we'll discuss about a Leibniz test. So, before going to Leibniz test, you have to learn alternating series. Alternating series is in the form of un minus un minus u2 plus u3 minus u4 plus so on. Is called an alternating series. That is alternatively plus or minus, which is known as a alternating series. When I have an alternative series, to discuss the convergence about alternate series, we have to use Leibniz test. So Leibniz test says if an alternate series satisfies these two conditions, then it is convergent. That is un greater than u2 greater than so on un greater than un plus 1. That is first condition. And second condition, limit un as n tends to infinity 0. If two conditions satisfied, then alternative series converges. Okay. And also the series is said to be absolutely convergent if the series sigma mod n is convergent. If sigma mod n is convergent, then we say that the given alternating series is absolute convergent. And the series sigma un is said to be conditionally convergent if it is convergent but not absolutely convergent. That means alternating series converges but sigma mod n diverges. Then we say that it is conditionally convergent. Okay, right. Test for the convergence of sigma minus 1 whole power n minus 1 into 1 by n root n. Whenever we observe minus 1 whole power n minus 1 whole power n minus 1, then immediately we conclude that it is an alternating series. Okay. So the given series is an alternating series. Un is 1 by n root n. So it is the nth term. You write 1 by n root n, which is greater than 0. And un plus 1 is simply replace n for n plus 1. So to proving un greater than un plus 1, you write n root n, it is certainly less than n plus 1 root n plus 1. And take the reciprocal, inequality will be reverted. 1 by n root n greater than 1 plus 1 by n plus 1 root n plus 1. So 1 by n root n, 1 by n root n is un, 1 by n plus 1 root n plus 1 is un plus 1 for all n belongs to capital. So first condition proved. And go for second condition, limit un as n tends to infinite, which is 0. First and second conditions are satisfied. So by Leibniz test, the given series is convergent. And again, test for the convergence 1 by 1 into 2 into 3 plus minus 5 by 3 into 4 into 5 plus 9 by 5 into 6 into 7 minus 1. We have plus minus so that it is an alternating series. You write un as 1 by 2n minus 1 into 2n into 2n plus 1, which is greater than 0. And also we know that u1 is greater than u2, greater than u3, so on. So we write un greater than 0 and un greater than un plus for all n belongs to capital N. First condition satisfied. And go for second condition, limit un as n tends to infinity. It is certainly 0. First two conditions are satisfied. Therefore, by Leibniz test, the given alternating series is convergent. And again, test for the convergence for absolute convergence or conditional convergence. To decide absolute convergence or conditional convergence, first you decide alternating series. Un is minus 1 whole power n by into n by n square plus 4. So you take n by n square plus 4 as un dash. Okay. which is un dash is n by n square plus 4, which is greater than 0 for all n belongs to capital N. Clearly, un dash greater than un plus 1 dash for all n belongs to capital N. And also we write as un dash is a decreasing sequence of positive terms. Both are same. Now calculate limit un dash as n tends to infinite. Here numerator degree is less than denominator degree, so the limit value is 0. First and second conditions are satisfied. So by Leibniz test, given alternating series converges. Now take modulus un. Modulus un in the sense modulus of minus 1 whole power n into n by n square plus 4. So modulus of minus 1 whole power n is positive, n by n square plus 4. Okay. Whenever we apply modulus, minus 1 whole power n becomes positive. So 1 by n into 1 plus 4 by n square. This is positive term series. So Vn is, choose Vn as 1 by n. Of course, we know very well about comparison test. Okay, by P series, sigma Vn is diverges because whose P value is 1. Limit mod un by Vn as n tends to infinite, which is not equal to 0. By comparison test, sigma Vn and sigma un behave alike. That means here sigma Vn diverges, sigma un also diverges. So by comparison test, sigma mod un diverges. Okay. But alternating series is convergent. But modulus un, sigma modulus un is divergent. So we say that it is conditionally convergent. If alternating series converges and modulus un diverges, then we say that it is conditionally convergent. Sigma minus 1 whole power n by 6n power 3 by 2. It is also same. You take un dash as 1 by 6n power 3 by 2 greater than 0 for all n belongs to capital N. So un dash greater than n plus 1 dash for all n belongs to capital N. First condition satisfied. Or you write un dash is a decreasing sequence of positive terms. Limit un dash as n tends to infinite, which is 0. First and second conditions are satisfied. Therefore, by Leibniz test, sigma minus 1 whole power n un dash converges. That is, alternating series is convergent. Now take sigma modulus un. It is sigma 1 by 6 n power 3 by 2. We say directly it is convergent because by P series it is convergent. Whose P value is 1.5, which is greater than 1. So by P series, sigma 1 by 6 and power 3 by 2 is convergent. So sigma mod n convergent. So that we say that it is absolutely convergent. And prove that converges absolute or absolute convergence. For proving absolute convergence, simply you take sigma mod n. First you write nth term. Okay. Sin x by 1 cube minus sin 2x by 2 cube sin 3x, so on. Each can be written as sigma sin nx by n cube. Okay. You take un is sigma sin nx by n cube. And okay, this is un minus 1 whole power n minus 1 sin nx by n cube. Okay, now consider modulus un. Is, sorry, right. So modulus AB can be written as modulus A into modulus B. So modulus minus 1 whole power n minus 1 into modulus sin nx by n cube. So modulus minus 1 whole power n minus 1 is 1, right? And finally we have is positive. So sin nx lie between minus 1 and plus 1. So that we write as, okay, okay, I showed here. So according to this, okay, sigma mod un is less than or equal to sigma 1 by n cube. Sigma mod un is less than or equal to sigma 1 by n cube. Okay. Sigma 1 by n cube is convergent by p series because whose p value is 3, which is greater than 1. We conclude that sigma mod n is convergent. When sigma mod n is convergent, it is absolutely convergent. Okay, that's enough. Because why we use this inequality? So by using this inequality, we can give a conclusion of convergence. That's why we use this inequality. Since modulus sin nx less than or equal to 1. Sin A is bounded between minus 1 and plus 1. That's why we use this. Okay. Thank you very much.